So now we want to look at solving other types of equations. So we're still working on SLL number 2, and we're going to talk about how to solve equations containing radicals, solve equations containing rational expressions, and solve equations that are in quadratic form. So let's first talk about radical equations. An equation with one or more radicals containing a variable is called a radical equation. The basis of solving radical equations is to eliminate the radical by raising both sides of the equation to a power equal to the index of the radical. However, some or all of the solutions to the new equation may not be solutions to the original radical equation. For this reason, it's necessary to check all potential solutions to the original equation. So our steps are to first isolate the radical, in other words, get it by itself. If an equation has more than one radical, choose one of the radicals to isolate. Then you're going to raise each side of the equation to the power equal to the index of the radical and simplify. Solve the resulting equation. If your equation still has a radical, you're going to repeat steps 1 and 2. And then check potential solutions in the original equations. Now, in solving radical equations, extraneous solutions, or fake solutions, potentially occur only when each side of the equation is raised to an even power. Therefore, an equation with only odd index should not and will not have extraneous solutions. So here's some examples. So if we're asked to solve this, the first thing we would need to do on A here is we need to add 2 to both sides. And then since my square root, my index is 2, I would need to square both sides. When I do that, that gets rid of the square root. That gives me 2x plus 1 equals 25. We just solve that as a regular equation. Get my solution. Now, it's not really a solution yet. It's a potential solution. It could be a fake solution. So we then check it. I go back to my original equation. So I go back up here and I insert that answer 12 and work it out. If I get the same number on both sides, it checks, and that would be our solution. Let's try this next one. So again, we would do the same thing. I first need to get that radical by itself by subtracting 1 from both sides. I'm going to have to square both sides. This side's easy. That's 6x plus 1. This side, we need to FOIL that out. So we want to rewrite that as x minus 1 times x minus 1. FOIL that out. That'll give you x squared minus 2x plus 1. This is a quadratic equation, so I need to get 0 on one side. So we'll take away 6x and take away 1 from both sides. That gives us 0 equals x squared minus 8x. That's actually very easy to factor. Just factor out an x. And that's going to give us 2 potential solutions, namely x is 0 and x is 8. So we have to go back to our original equation. First plug in 0, see if it works. And then plug in 8, see if that works. Now, when we plug in 0, we run into a problem. We get 2 equals 0. That does not work. That means this is a fake solution. X equals 0 is a fake solution. I need to toss that out. When I check the 8, that does end up working, so that checks. So even though we had 2 potential answers, only one of them worked. And when you have like 2 potential answers, sometimes they both work, sometimes one works, and sometimes none of them work. So let's go ahead and turn the page. Okay, so now we're ready to go through and solve. So first thing we got to do is get x, the square root of x by itself. So I'm going to need to go ahead and subtract 4 from both sides. Gives me square root of x equals 3. So we next are going to go through and we're going to square both sides. So this side just becomes x. 3 squared is 9. Now I need to check. I got to check x equals 9. And that means I go back to my original equation and I'm going to plug in 9. That's supposed to be an equal sign. Square root of 9 is 3. 3 plus 4 does equal 7. So this does check. So that means 9 is my answer. Let's try number 2. So I've got to get that square root by itself. So I'm going to add 2 to both sides. And now I want to go and square both sides. So when we do that, that's going to give me x equals a positive 25. Now, I'm going to need to check this. So I'm going to go back to my original equation. Plug in 25. Square root of 25 is 5. 5 minus 2 is a negative 3. Or sorry, positive 3, excuse me. In either case, that does not work. Just to make it easier, I'm just going to write the word no. It does not work. This is false. That was my only potential solution, and it didn't work out, so this thing has no solution. Now, sometimes you'll see them use a little O with a line through it. That means solution, no solution. Or you might see them use an empty set of curly brackets. Alex likes to use the empty set of curly brackets. All right, let's try this next one. So now my index is 3. So again, I got to get that radical by itself. So I'm going to add 1 to both sides. So that gives me the cube root of 4x minus 8 equals 5. And so now I want to go ahead and I want to cube both sides. So when we do that, that gives us 4x minus 8 equals 125. Again, you can enter that in by typing 5. Use your caret key right here. Type a 3, 125. Then we're going to add 8 to both sides. So that gives us 133. And then we're going to divide by 4. Now, since I raised both sides by an odd power, I don't need to do the check. It should work. However, if you want to check it, there's nothing wrong with doing it. Let me show you how to do it on a calculator. So, I want to show that this left side here is going to be equal to the right side when we replace x by 133 over 4. So, first thing I need to do is I need to get a cube root into the game. So, I'm going to type a 3. And then I'm going to hit my second key and then my caret key. Make sure that 3 slides up. It should slide. That means you got the cube root. So we're going to do 4 parentheses. Now I'm going to put this answer in as a fraction because that's the way Alex likes it. So fraction key 133 over 4. Subtract 8. Now I want to put that minus 1, but notice that minus 1 is outside the radical. So I need to hit my right arrow key. Make sure I slide outside of that. Do my minus 1. That does give me 4. So it does check. All right, let's try number 4. So we've got a square root, so it's going to be mandatory to do the check on that one. So we're going to take away 6 from both sides. Square root of 9x minus 15 equals a negative 4. So now I want to square both sides. And since I'm raising both sides by an even power, I'm going to have to do the check on this one. So that gives us 9x minus 15 equals 16. We're going to go ahead and add 15 to both sides. So that's 31. And then divide by 9. And I'm just going to leave that as a fraction, 31 over 9. So again, we have to do the check here because we raised both sides to an even power. So I'm looking at the square root of 9, 31 over 9, plugging that in, minus 15. Remember, I'm going back to my original equation. And I want to see if all that is equal to 2. That's our question mark. Okay, well, again, I don't really want to do that by hand, so we'll make our calculator work. That's the square root. Oops, my bad. And then we have 9 parentheses 31 over 9. Close the parentheses. Subtract 15. Make sure we move that cursor out from the radical by hitting the right arrow key. Plus 6. And we see we get 10. 10 does not equal 2, so that would be false. This gets rejected. That means we have no solution. All right, let's try the next one. Ooh, okay. Well, the good news is the radical is already by itself, so we're just going to go ahead and square both sides. You square this side as well. So this side's 4x minus 15. This side we need a FOIL. So you're going to rewrite that as x minus 2 times x minus 2. And that would give us x squared minus 4x plus 4. And now we want to go and get everything to one side. So I'm going to go ahead and subtract 4x from both sides. Add 15. Oh, there's got to be a typo here. Oh, I think I know what the typo was. All right, my bad. So let me back up here. There's a typo in this problem. this 2 should have been a 5. My bad. So that's going to change this here. When you FOIL that out, that's going to give you 10x and 25 here. Okay, so now we're in business. So we're going to subtract 4x and add 15 to both sides because I want to get 0 on one side. So this would be 0 equals x squared minus 14x plus 40. This thing actually factors. Look at 40. 40, 4 times 10. Both of them are going to have to be negative. Because if I do 1 times 40, that's 41. 2 times 20, that's 22. 4 times 10, that adds up to 14. We just have to make both of them negative to get my negative 14. And since the coefficient of the squared term is 1, that's going to be x minus 4 times x minus 10. We're going to go through and set each factor equal to 0 and solve. So when we go through and solve this first one, I add 4, it gives me x equals 4. And the second one, we get add 10 both sides, we get x equals 10. So now to check our answer, let's first check x equals 4. So I'm going to go back to my original equation, which should have been x minus 5 here. So we'll go ahead and make that correction. So that gives us 16 minus 15 is 1. Square root of 1 is 1. 4 minus 5 is a negative 1. This is false. So we're going to reject this one. So that one's out. Let's try the 10. So I'm plugging in a 10. That's 40 minus 15 is 25. Square root of 25 is 5. 10 minus 5 is 5. That checks. So we're going to keep the 10 and we're going to reject the 4, so my solution here would be 10. Now let's take a look at this last one here. So my index here is odd, so actually I don't have to worry about doing the check. That's nice. So I'm going to cube both sides. And here's the nice thing, since they both have odd root, both for the cube root, when I cube I just get 2x plus 4 on this side and 4x minus 8 on the other side. And it makes it really easy. Remember, I want to get my x's on one side, numbers on the other side. So I'm going to subtract 2x from both sides. And let's go ahead and add 8 to both sides. So that gives us 12 equals 2x. Divide both sides by 2. That's going to give us 6. I don't need to do the checks as odd root, but I can. 2 times 6 is 12. Plus 4 is 16. That's the cube root of 16. 4 times 6 is 24. Minus 8 is 16. That's the cube root of 16. Cube root of 16 equals cube root of 16. It does work.